Alright, so now it's time to look at characteristic function. What is a characteristic function? It defines the strength of relationships. So for example, if the value of characteristic function is 1, that means there is a complete relationship between the two sets or the two elements. And if the characteristic function is 0, that means there is no relationship at all. So therefore, as you can guess, in fuzzy logic we can go from 0 to 1. Therefore the characteristic function values go from 0 to 1. Therefore we can have strengths of say 0.5, 0.6, 0.7, and we can then set a threshold value. Like I'm talking about the applications, we can then set a threshold value, like we want the strength of the relationships to be this much, then we'll allow them in the set or anything like that. There are two types of relations: unconstrained relation and constrained relations. So what are unconstrained relations? In an unconstrained relation, every element of a universe is completely related to every element of another universe. So there is a very special case of unconstrained relations. Since every element of one universe is related to every element of another universe, therefore it forms a universal set. What is a universal set? In a universal set, we denote all the sets of the universe, and it includes the null set, it includes the set of 2, the set of 3s, everything. So for example, if I have a set say 1 2 3 4, okay, so what is a universal set? A universal set consists of all the universal set can be formed by including all the sets that can be formed from the set 1 2 3 4. What is the universal set in this case? Okay, so this is the universal set that we get. This was unconstrained relation. Every element of one universe is completely related to every element of another universe. What are constrained relations? It says not all elements of one universe are related to all elements of another universe. So some elements might be related to the elements in another universe, some might not be. And the special case in constrained relation is that we know that obviously an element will always be related to itself. Therefore, it forms an identity set. We have all done this in basic set theory in mathematics. So we got one universal set from unconstrained relation and one identity set from constrained relations. And now let's go on to another term, cardinality. What is cardinality of relation? The cardinality is the total number of elements in a universe. Okay, so for example, we consider a universe X which has say 10 elements. So the cardinality of universe X is 10. Therefore, for a discrete universe having countable finite number of elements, we have a finite cardinal number. And similarly, for continuous universes having infinite collection of elements, we will have an infinite cardinal number. Cardinality is usually denoted by the letter n with a subscript of the universe of which we are talking about. So if we are talking about say universe X, then its cardinality is n subscript X. So now let's assume there are two universes. One is X, another Y. X has n elements, Y has m elements. So their cardinality respectively would be n subscript X and m subscript Y. Then if there is a relation between X and Y in the universes X and Y, then their cardinality would be n X into n Y. Now let's go to the operations on crisp relations. So these are the basic operations that many of you must already be knowing since you are already studying about fuzzy logic. So I am assuming that you already have the knowledge, but no worries, I'll explain it in brief. So the operations are union. So the union of two sets means combining all the elements. Then there's intersection, which means making a set of the elements that are present in both of them. So it's you can assume it to be an, not assume, it's actually the AND operation. It has to be in the first set, has to be in the second set, right? Its value should be 1 and 1 in both, so the answer is 1, otherwise 0. And in union can be seen as the or logic function, so it can either be in one universe or the another universe, and it will be included in the final set. Complement of a relation is 1 minus the relation itself. So, and containment, so we can say R contains S. It is denoted by R, sidewards union symbol, and then S. And we will get into detail of these operations in the next video. I wanted to keep this video short so that you get the grasp and the summary of what we are going to focus on. So we are going to focus on the basic properties of a crisp set, and then we'll move to fuzzy set. So you'll see that the transition makes it very easier to understand fuzzy relations once you already understand crisp relations. So in the next video, I'll be talking about union, intersection, complement, containment. Okay, and there are some implications that we'll be making, and it will be simple. So see you guys next time.